So we're kind of breaking this down into 2 days. Today we're focusing primarily on the vocabulary and being able to find the different parts. And then tomorrow we're going to focus on the graphing part of it, even though there is, to some extent, we do have to still kind of take a look at the graph to be able to demonstrate some of these different things. Okay, so let's start with general form for the sine and cosine. So general form is this. It's y equals a, and I'm just going to use the sine curve for this example, bx plus c plus d. Now, if you remember when we talked about all of our other types of graphs, whether it be a quadratic, remember we did that little lab with the families of graphs. This still fits kind of the same thing. You think about, what did the number or letter outside the parentheses do to our curve when we studied the different families of graphs? Where did it move the curve? Anybody remember? Luke?
Wouldn't the C move it to the left and then the B would move it up?
You got it. So inside the parentheses is moving it left and right. Outside the parentheses is moving it up and down. Okay, so that still works even for these sine and cosine curves. As we look at these other letters, so the amplitude, okay, the amplitude, we always take the absolute value of that. So it's always going to be a positive value. So for right now, we're just going to write that down. Basically, the amplitude, if we go back to the curve that we have already graphed, let's take this sine curve that we graphed here. So the amplitude basically is going to be this distance from the top of the curve down to our starting point. So in this particular graph, the a value is 1. So you can see it's kind of the height there of it from the origin, or from this x-axis. Okay. The reflection, if we're looking at the curve, would be if a is negative. So there's going to be a reflection of your curve. If I was doing, going back to my sine curve here, if my a value, if it were negative sine of x, now instead of this curve going up, the reflection, it's going to start by going down, and then it would go back up. So it would be kind of just the opposite of this curve. Again, we're talking about a reflection across the x-axis. Okay, we say the period is 2 pi divided by b. Now we say 2 pi divided by b. The period represents the distance of one curve. So again, as I'm referring to the sine curve here, in this picture, the distance of one curve goes from 0 all the way to 360. So that would be one curve. And when we start making our graphs, we're going to make 2 curves. So we also know that 360 is 2 pi. If you remember back before break, we were talking about the unit circle. Okay, the interval. You say the interval is the period divided by 4. So we're going to break the period into fourths. And that will give us what we're calling our interval. Again, referring back to my sine curve, if I were to take 360 and divide it by 4, my intervals would be 90, 180, 270, 360. In terms of pi, if I were to take 2 pi and divide it by 4, that would be pi halves, pi, 3 pi halves, and 2 pi. Okay, so for our phase shift, again, our phase shift is going to be our movement left or right. Basically, to figure the phase shift, we're going to take the bx, so we're going to set bx plus c equal to 0, and then we're just going to solve that. And again, this is my horizontal shift left or right. Okay, my D value is the vertical shift. We kind of talked about that earlier. Again, that's going to move the graph up or down. Now we say we're moving it up or down. We're moving it up or down from the midline. If I'm using this example of my original sine curve that we made on our lab, the midline is the x-axis on here. But notice on this curve, there's no there's no vertical shift on this one. So if the D value would be 2, then obviously that's going to move my starting point up 2. Okay, the domain obviously is all of our x values. That's not changed. And our range is also not changed. That's also our y values. Let's take a look at an example here. So the example we've got here is f of x equals 3 sine of x minus 2. And all we're going to do is we're going to go down through and we're going to identify all the different parts today. So when you do your homework tonight, all we're focusing on is you finding the different parts. Tomorrow we're going to specifically focus on, you know how to find the parts. Now you're going to put it into graph form. So amplitude. For identifying the amplitude, we know our A value in this problem is a 3. So the absolute value of 3 we know is 3. So my amplitude is 3. Next, is there a reflection? Well, we're going to look at the A value. The A value is positive, so there's no negative, so we'd say no reflection. Next, we're going to find the period. Remember the period, we're going to take 2 pi divided by b. Well, in my problem here, b, the value in front of x is just 1, so that makes my period just 2 pi. Next, we're going to find the interval. So the interval is going to be this 2 pi divided by 4. Well, 2 pi divided by 4 is pi over 2, so pi halves is going to be my interval. Next, we're going to see, do we have a phase shift? Remember the phase shift, we're going to set the bx plus c equal to 0. This is just in the parentheses. On this one, we just have x. So x equals 0, so there's not a shift left or right. And then last would be finding the vertical shift. In this case, we've got a -2 for our d value, so there's going to be a vertical shift down 2, or -2. Now, let's talk about what that looks like when we kind of transfer, just so everybody understands what all the different parts mean. So when I'm making this graph, we're going to make 2 periods, which basically means we're going to make 2 curves. So here's my y-axis. My period is 2 pi. So we're just going to go ahead and make, into 4 parts here. I'm going to go to the right 4, and I'm going to go to the left 4. This is one we know we don't have any kind of horizontal shift. So one full curve is going to be 2 pi, from 0 to 2 pi. If I want to make my other curve, again, going to the left, again, that would go to -2 pi. Because we know the interval here is pi halves, that's what I'm breaking this 2 pi into. So from 0, this would be pi halves, and then pi, and then 3 pi halves. And then I could do the same thing going negatively, -pi halves, -pi, -3 pi halves. Now, this is a sine curve. If you remember from our little lab, we know it's an S shape. So sine's an S shape. Normally we start at the origin. This one does have a vertical shift down 2. So what that does is that moves my midline. So if here's 1, here's 2, you might just draw in kind of a dotted line. That's my new midline for my curve. So I'm going to start right there on the y-axis. My amplitude is 3. Okay, so if my amplitude is 3, I'm going to go up 3 from that point. So 1, 2, 3 is going to take me up to that value. So I'm going to put a point that's going to be the top of my curve. Then I'm going to come back down to my midline at pi. I'm going to go back down 3 more. And then I'm going to come back up and finish my S. So here's one of my curves. Goes here, down, and finishes there at the midline.